Assalamu alaikum. Myself, Dr. Ansari Farzana Veduzama, Department of Chemistry, J.A.T. Arts, Science and Commerce College for Women, Malegaon. Welcome all of you. In the previous presentation, we have seen the introduction of chromatography, types of chromatography, and also principle of column chromatography. Today, we shall continue the principle of column chromatography. In partition chromatography, separation of component of the mixture takes place due to differential partition, that means distribution, between a stationary liquid phase and mobile liquid phase, and not due to differential adsorption. In this, cellulose, starch, silica gel, and such other inert solid acts as a support to stationary liquid phase. Now, ion exchange chromatography. In this type of chromatography, separation of component is achieved by exchange of ions between the stationary solid phase called ion exchanger and the component present in the mobile phase. Thus, ion exchange is a process in which an interchange of ions of like signs takes place between solution and essential insoluble solid, that means ion exchanger, in contact with solution. This technique is useful in the separation of ions or compounds of similar properties. The ion exchangers are insoluble substances which binds ion in such a way that the ion may be easily and reversibly replaced by other ions from solution when brought in contact with ion exchanger. It is the kind of adsorption chromatography. The solid molecules are trapped in the pores of the stationary phase and are removed from the flow of mobile phase. The stationary phase is referred to as a molecular sieve. These sieves are usually polymeric molecules which are hydrophilic and are capable of absorbing water, due to which they undergo swelling, causing an opening of the structure. The average time that a solid molecule is spent in the pore depends on their size. Solvated molecules that are larger than the average pore size of the packing material cannot enter into the pores, thus suffering no retention and travel through the column at a rate of the mobile phase. Solvated molecules that are smaller in size than average pore size can be penetrated into pores and entrapped for the largest time. Between the largest and the smallest molecule are intermediate size molecules whose penetration into the pores and retention time in the pores depend on their diameters. Ion exchangers, ion exchange resins, these are the solid, also called resin, which have high molecular weight. They must fulfill some conditions, such as the resin must be sufficiently cross-linked to have only a negligible solubility in water. Cross-linking increases the rigidity of resin, reduces swelling, reduces porosity, and reduces the solubility of resin in water. The resin must contain sufficient number of accessible ion exchange group. The resin must be hydrophilic to permit diffusion of ion through the structure at a finite and usable rate. The swollen resins must be denser than water. The resin must be chemically stable. Also, The resin must not have cavities big enough to allow easy escape of ions. Ion exchange resins are of two types: cation exchanger and anion exchanger. Cation exchanger exchange the cation and anion exchanger exchange the anion. The most functional group of ion exchangers are SO3H, COH, OH, SH, anions such as NH2, NHR, NR2, NR3. Action of ion exchange resins. Cation exchange resin. They are polymers which contain sulfonic and carboxylic group as an integral part of the resin and an equivalent amount of cation. The group from which ion can be exchanged are known as exchange site. The cation exchange resin contain ions which are capable of exchanging cation flowing in the solution without altering the major physical properties of resin. The exchange reaction can be shown. In this reaction, RH plus M plus ions is from solution which is exchanged and converted as Rm plus H plus, where M is the cation and R is the resin anion. The commercially available resin generally contains Na ion in place of H ion. This increases the exchange ability of the resin. Cation exchange resin are further divided into two types: strong acid resin such as polystyrene sulfuric acid resin. They contain a highly insoluble group like SO3H. The exchange strong acid resin is less. The resin is effective over a wide range of pH from 1 to 14 in acid as well as in salt form. Strong acid resins completely remove the cation of even a very weak base. The resin are also useful for separation of amino acid, rare earth, vitamins, peptides, etc. A polystyrene polymer cross-linked with divinylbenzene and sulfonated further is an example of strong acid resin sold under their trade name as Dovex 50, Umberlite IR 120, Dolite C20. Second exchange resin is as weak acid resin. Polymethyl acrylic acid resin is the example of weak acid resin. They contain a partially ionizable group like carboxylic group. The exchange capacity of weak acid resin is generally more than that of strong acid resin. The resin is effective over a limited range of pH 5 to 14 in acid as well as salt form. The weak acid resin does not remove completely the cation of weak base. This is similar to the incompleteness of weak acid and weak base reaction. These resins are useful for separation of transition metals, acids, antibiotics, organic bases, etc. Certain weak acid resins sold under the trade name are Umberlite IRC50, Permutite H70, Resin 120. Anion exchange resin. They are polymer which contain amine or quaternary ammonium group as integral part of resin, and the equivalent amount of anion, the group from which ion can exchange, are known as exchange site. The anion exchange resin contains ions which are capable of exchanging anion flowing in the solution without altering the major physical properties of resin. The exchange behavior can be shown in the next PPT, next presentation.